Here's a problem one of my students had trouble with the other day. We're trying to find kinetic energy post-collision, after a collision occurred. So the actual problem was that two masses, each weighing 1,000 kilograms, are moving with the same speed of 12.5 meters per second, and they're approaching each other. Ooh, sounds like bad times. Now, they have a head-on collision, and they bounce off away from each other, assuming this is a perfectly elastic collision. Now, if we remember, perfectly elastic means that there's no energy, there's no mechanical energy lost during that collision. So we're going to change the representation of this problem. We have two masses coming at each other, both of which are 1,000 kilograms, and they're coming at each other with the same velocity. So this is pre-collision. They're both coming at each other at 12.5 meters per second. Post-collision, they both move away from each other. And we don't know what those velocities are. Let's call this mass A, this mass B. We don't know what those velocities are post-collision. However, I do know with the conservation of mechanical energy, and because this is a perfectly elastic collision, I know that the mechanical energy initially or pre-collision is going to be equal to the mechanical energy post-collision, or in the final moment. Mechanical energy is the combination of your potential energy and your kinetic energy. So if I add up all of the potential energy to all of that kinetic energy before, it is going to be equal to all of the potential energy plus all of the kinetic energy afterwards. Well, they're starting out at the same level. There's no springs involved, so there's no potential energy, spring potential. There are no hills. We're not changing elevation in any way, shape, or form. So there is no potential energy before or after. There's only kinetic energy. We have two objects. That's what's in our system, those two objects. So the kinetic energy is going to be 1/2 mass times velocity squared. That's what kinetic energy equals. And we have to consider both objects. So we have the kinetic energy of object A before the collision, and we're going to add that to the kinetic energy of object B before the collision. And because it's perfectly elastic, it is going to be exactly equal to that kinetic energy after the fact. Now the problem was asking us, what is that kinetic energy of the system after the collision? So look at that. We don't even need to break this down into what the final kinetic energy equals, because that's all we want to know. We only want to know what that final kinetic energy is. So if we can calculate what that total kinetic energy is before the collision, we have our answer, because we were told it's perfectly elastic. So let's go ahead and plug in our numbers. So we can see that our kinetic energy, when we take into consideration the original problem, the minimum significant figures we had were 2. We can say that our kinetic energy is 1.6 times 10 to the 5th joules. That's what the kinetic energy was before and after that collision. If you have any questions, post them in the comments. Do you have your own physics problem you want to go over? Fantastic. Go ahead and copy and paste it right into the bottom, and I'll make a video for you. Get your homework help here at Shae1st Physics and subscribe today. Make it a good one. Bye-bye.